Okay guys, let's take a look at today's lesson. We're going to be talking about laws of logarithms today. Many of the things that we're going to be talking about you would have learned last year, but there are some things that you would not have, so let's kind of dive in here. These laws are pretty significant. Let's kind of go through them. So the first law is, notice we have a product in our argument. We are allowed to expand this and say log base b of m plus log base b of n. You may remember that from last year. So if you have a product in the argument, you would use addition to expand. If you have a quotient in the argument, then you would use subtraction to expand. We kind of remember that, hopefully. If, like law 3, we know if we have bases that are log base b equals log base b, then we can set our arguments equal to each other and solve. So another, basically equation technique. This last law is one where if the argument is taken to a power, then I can take that power and bring it to the front. Okay, so that is another law. And let me kind of go into this law just a little bit more. So for example, so let's say we have log base 2 of what? X cubed. So we have that option. And we have log base 2 cubed of x. These are very, very different. We treat them completely differently. Really important for us to understand. So this, the argument is cubed. So I could use a rule for that. I could bring the 3 down, and this would be my expansion. This is not like that. This is the log itself is cubed, not the argument. If I were to write this out, this is the same thing as log base 2 of x times log base 2 of x times log base 2 of x. These are completely and totally different, and students sometimes get those two things confused. It is significant as to where the exponent is. Is the exponent on the argument, or is the exponent on the logarithm? That will make a big difference in how we would handle that. Okay, so I wanted to point that out. That's a common mistake that we make. I want to make sure we don't make that mistake. Okay? Laws, those logarithm laws actually are huge in calculus. We use them all the time. So if these kind of have slipped your mind, you're like, oh, that's not a big thing. It is a huge thing. In fact, anything to do with logs in calculus, they are going to mess with log laws. It's just going to happen. I mean, they're going to take whatever the answer is, and they are going to mess with it until it's like tiny. They're going to. So we really need to know those laws well in order to be successful. Okay? So are we okay on those first 4 laws? Are those all right? So let's look at the change of base formula. Last year you probably used it for numbers purposes, numerically. Like in the old times we used to use it because we didn't have a calculator that had that log change of base formula like our calculators now have now. So we would use it to like turn everything to log base 10 to find an answer, a number answer. We really don't use it for that. I mean, that's okay. You can use it for that, but that's not going to be my focus on using it. You actually can use this to solve equations. We're going to be working with the change of base formula to solve equations, okay, not to just get a number answer. Okay, so that's this is going to be a new focus for us this year, is to use it algebraically, not numerically. Okay, and we have an example for that. Okay, so we okay so far? All right, let's jump to our examples. Let's go to that next slide. Okay, so we'll start over here at number 1. It says evaluate. That word evaluate is important. It typically means find the answer. Right, there's going to be a numeric answer. That's normally what it means. Evaluate. Find the numeric answer. Now, sometimes I can evaluate these expressions separately, right? So, and I probably, I might have some luck doing them separately. And it's okay. If you do, you can. Or I could combine those together first. And those are options for us. So really, it's whichever way you want to do it. I'm fine with that. Since we are working on expanding, condensing, I'm just going to combine those together. So it's an addition, so we would combine the arguments by multiplication. So this would turn into log base 4 of 2 times 32, which is log base 4 of 64. So we look at that. We can think about that as the one like we did yesterday, where we set it equal to a variable like x. And I have 4 to the x equals 64. So I make the bases the same. 4 to the x equals 4, what is that, cubed? So my answer to this is 3. Now you can write x equals 3 if you want to, if you're doing that technique. Really, we invented the variable x and put it in there, right? It's not part of the equation, so technically it's really not, what we're looking for. We're just looking for that value, and 3 would be the value. And you don't have to do this equal x and go through that. If you can do this in your head, I'm fine with that. You would think to yourself, 4 to what power is 64? You could do it that way. 4 to what power is 64, and then just come out with 3. Okay, we okay with that first one? Let's look at the next one. So on this one, and I'm not a fan of big numbers, so I really like being able to take this 3 and move it into the front, so that's what I would do. 3 log base 2 of 16. So now I'm going to have 3 times, and I'm going to turn that to an exponential, or again, maybe you know the answer already, which is fine. So 2 to what power is 16? Okay, so we have 2 to what power is 2 to the, what, 4th? So basically I have 3 times 4, or 12. Okay, how are we with that one? Okay. All right, let's do our expansion one down here at the bottom on number 2. So this 3 just belongs to the x, and the 6 just belongs to the y. We need to be sure we are aware of that. I can't take these out front, right? The whole argument would have to be taken to a power for me to bring it out front right now, right? So I can't do that first. I have to, there's a product, so I'm going to split them apart first by addition. So this would be log base 5 of x cubed plus log base 5 of y to the 6th. Okay, so I have them separated. Now I do have the entire argument cubed and the entire argument to the 6th, so I can bring those numbers forward. So I have 3 log base 5 of x plus 6 log base 5 of y. And that is completely expanded. Sometimes students want to know, well, how do I know if it's completely expanded? What do I know? How can I figure that out? What I want you to do is focus on the argument. Focus on the argument. There's really only 3 things we can do with the argument. If the argument has multiplication in it, we can expand it. If the argument has division in it, we can expand it. If the argument is, the whole argument is taken to a power, we can expand it. Other than that, we cannot do anything. Okay? Can't do anything. So for example, if I had log base 2 of x squared plus y squared, can I expand that? No. I can't expand a sum. That's not a thing. I can't, there's no power. I mean, it's to the first power, right? I could bring a 1 down, but that doesn't really do anything. So I don't have multiplication. I don't have division. I don't have the whole argument to a power. There is nothing I can do to expand that. So really important for us to recognize when we can expand things and when we can't. Okay? So let's look at this last expansion one over here. I've got some division going on, so I would do that first. So natural log of x minus natural log of y to the 1/2. Okay. This one's done. I don't have any more additions, multiplication, division, powers. Still got some room to move on this one. I'm going to move that 1/2 down. So I have natural log x minus 1/2 natural log of y. And there's my expansion. Okay. So now let's go the other way. Let's condense them or combine them together and shrink them. So let's look at this one. This 1/3 just belongs to the 64, doesn't belong over here, so I've got to bring up the powers first before I combine them together. So I would do log 64 of 1/3 to the 1/3 plus log 5 squared. Okay, so yes, we can combine those together right now, but why don't we see if we can't fix them up a little bit, maybe, work on them. So is there a cubed root of 64? There is, isn't there? So what cubed is 64? 4. So this is basically log 4, right? I just simplified that number. 64 to the 1/3 is 4. And we know what 5 squared is, right? We've been working with the squares for a long time. Okay, so that's a little bit easier to work with. So now let's use our condense. Let's keep condensing. It's a plus, so I'm going to condense by multiplication. So log 4 times 25, or log of 100. Now I've condensed it to one log, but let's keep looking at it. Let's make sure there's nothing else, where our goal is to shrink it as small as possible. It is pretty small right now. Okay, is there a way to make it even smaller? There is, isn't there? Because this is base 10. 10 to what power would give us 100? 2, right? So this is 2. So that's as small as I can make that. That's a 2. Now it's interesting, I want you to understand, when it says combine, we actually ended up evaluating. That's a little unusual. It doesn't always end like that. Sometimes you're just combining and condensing, and that's all you can do. But if you can keep going, you should. If you can keep going, you should. Does that make sense? Okay. Even though it doesn't say evaluate, we could keep going, so we should. All right, let's look at this B. This 1/2 belongs to this whole thing. So I'm actually going to just leave it alone right now, and I'm going to work on the inside. Normally, I'm going to work on the inside because I need to get that combined together. I'm going to do it in a couple of steps. You can just do it all at once if you want to. That's fine. I'm going to do the first two together first. So that's addition. So I'm going to multiply. So log base b of mn minus log base b of p. Okay, now I've got some subtraction going on, so I'm going to divide. So 1/2 log base b of mn over p. Okay, now my last step, It is, you're right, it's in order from beginning to end. Yes, unless there are parentheses involved, and then you would do it in order, like nesting them. All right, so I'm going to bring that 1/2 up into the argument. So you really have two different ways that you could write this argument. You could write it as an exponential. That's fine. If you like exponentials, we would stop. That would be our answer. If you would rather write it as a radical, you can. That's okay. We could say log base b of the square root of mn over p. So it really just kind of depends on which way. If you're not told, if there's no direction, you get to choose. Okay, so either one of those answers would be perfectly acceptable. All right, now to the new stuff. We're going to use the change of base formula to rewrite and simplify that expression. The reason that we're doing this is because we are preparing for for what we're going to be doing with equations. We're going to be using change of base formulas to solve equations. So let's look at that. So the change of base formula, on the other page, I'll just write it down here for us to look at. I didn't talk about it very much, so let's talk about it. So they use log base b of x equals log base a of x over log base a of b. Okay, so I can make a anything I want. Anything I want. It doesn't even have to be a number that's up here. I can make the base anything. I could make it base e if I wanted to. Doesn't matter. You can make the a anything. So keep that in mind. We have there's no limit to what we can make a. Okay, it has to be a positive number, right? We can't have like a negative or a 0, but we can make it anything. The argument of the numerator needs to be the argument of the original logarithm. The argument of the denominator has to be the original base. That's the change of base formula. Okay, so let's think about that. Let's look at these and let's think, well, what base would be convenient for us? Sure, I could turn them all to base 10, but how is that going to help me at all? I mean, I would just have log base 10 of x over log base 10 of 2. I mean, it really wouldn't help shrink anything. So we really need to look at the bases and see if we can figure out what would be best. I have a 2 and a 4 and a 16, and I don't even have to use 2, 4, 16. I can use anything. But it looks to me like base 2 would probably be the best bet for us when we have a 4 and a 16, you know. So let's change. This is already base 2, so let's leave that one alone, and let's change these two to base 2. Okay, so I have log base 2 of x plus. So I'm going to work on the middle one. I'm going to change that to log base 2. So this is log base 2 of x over log base 2 of 4. Okay, are we okay with the formula for that middle one? Now I'm going to use the formula on the last one. I have log base 2 of x over log base 2 of 16. And then let's step back and see what we have. Okay. All the ones with x I have as a log base 2. That's pretty good. And look what I have in the denominator of those two. Aren't they just numbers? Don't we know log base 2 of 4? Isn't that going to be just a number? Like 2 to what power is 4? Right, it's just going to be a 2. So this is going to work out kind of nice for us. So let's work on these denominators and simplify them. So I have log base 2 of x plus log base 2 of x over 2 to what power is 4? Right, it would be 2 plus log base 2 of x over 2 to what power would give us 16? 4. Okay. So basically I have 1 log base 2 of x plus a half log base 2 of x plus a fourth log base 2 of x. Right? I have 1 plus a half plus a fourth of log base 2 of x. So basically I have 1 plus 1 half plus 1 fourth. I'm going to add all those together, and of course I can't do that in my head, so I'm going to be finding a common denominator, which will be 4, right? So 4 over 4 plus 2 over 4 plus 1 over 4. So what, 7 over 4? So I'm left with 7 log base 2 of x over 4. And that's the technique that we're going to use when we solve logarithms in a little bit. Okay, condense them like that. Now, I have been asked, can I take the 7/4 and move it up into the argument? Yes, you could make x to the 7/4 if you wanted to. If we're solving an equation, we may not want to do that. It just depends on the equation. So you do have that option. Or you can leave it like that. I mean, for us, we can just leave it like that because our purpose was just to simplify, to rewrite and simplify. So our other option, this is perfectly fine. Our other option would be log base 2x of 7/4. And that's perfectly fine. Okay? If our instructions were to condense, we definitely would want to do this one. But our instructions are to simplify. So either of these works. Okay? So how are we? We ready?